Floodlighting is one of a kinds of lighting schemes that is prominently used in large surface areas, used for large surface areas like sports arenas, indoor, outdoor stadiums, etc. So first let us understand what floodlighting is. Then we are going to talk the mathematics of arranging the floodlights. So floodlighting means flooding of a surface area with light from powerful projectors. Everyone is aware of projector lights, okay, that you observe in your classrooms and laboratories where you have PPTs played. That is one of a kind of floodlight. So we'll be having a special reflector and housing is employed in floodlighting. So this is used to concentrate the light emitted from the lamp in a relatively narrow beam. So this is nothing but focusing a stream of illumination onto a particular surface or a area, okay, where you want exactly to project it. Okay, so this concept is called floodlighting. The item that you are using for floodlighting is called floodlight projector. So usually the floodlight projector, it consists of a reflecting surface. So this reflecting surface, it may be a silvered one, it may be a silvered glass one, it may be a chromium plate, or it may be a stainless steel surface. So any medium that is capable of or focusing a beam light of ray of light, okay, that is called a reflecting surface. Okay, whatever illumination or luminous intensity falls on its surface completely, it is thrown in the opposite direction. Okay, that particular kind of surface is called a reflecting surface. So out of all this, silvered glass, the efficiency of it is very high, along with the polished metal, which is 85 to 90%. So usually go for silver glass. Polished metal is a costly affair, so we generally do not use a polished metal, though it is efficiency is high. And polished metal's efficiency is about 70%. And usually metal reflectors, they are used only in the case where robustness is necessary. An important application of illumination engineering is floodlighting of large and open areas. So it is necessary to employ floodlighting to serve one or the following purposes. What are the purposes? So a floodlight is a broad beamed high intensity artificial light. So they are often used to illuminate outdoor playing fields. So illumination of outdoor playing fields is one of the purpose. So outdoor playing fields means outdoor sports events. Everyone is familiar that you are having IPL now. What is the floodlight lighting your lighting scheme you are using in IPL? Floodlights. So more focused kinds are often used on stage lighting instruments in live performances, such as concerts, plays, etc. In the top tiers of many professional sports, we require floodlights to allow games to be scheduled outside daylight hours. Okay, evening or night matches may suit spectators who have work or other commitments earlier in the day. So floodlighting has for the reason taken, a prominent role in day-to-day life. Some sports grounds we do not have permanent floodlights installed. They make use of portable temporary ones instead. So many large floodlights with gantries for bulb changing and maintenance are also used. So these are a few of the floodlight schemes that you can see. These I've shown here are LED type of floodlights. Okay, so you have got a rectangular array of LED lights, a square array of LED lights, to a set of LED lights. This is 100 watts capacity with Indian specification IP66 you are observing. And this is how the floodlights are arranged on top of a metal tower. This is how floodlights are illuminating, or floodlight luminaire is illuminating a stadium. What is the main difference between a floodlight and other luminaire? The main difference between the floodlight and other luminaire used in street lighting or general domestic lighting is that the former aims direction with respect to the light intensity axis. Okay, so the floodlight, it aims at a light intensity axis. That means street light luminaire is always aimed at a particular direction on the road surface spot wise, but floodlight isn't. It's going to cover large area. Understand? So this is what. So floodlight covers, as it covers large area. What is happening? Floodlight is used for objects such as buildings, hoardings. Okay, you have different kinds of hoardings. Okay, so all these kind of things you'll be having floodlights used. ఎక్కడైతే మీకు ఫోకస్డ్ లైట్ యూజ్ అవ్వదో అక్కడ ఫ్లడ్ లైట్స్ మీరు యూజ్ చేసుకోవచ్చు. So we require some photometric data before we design a floodlight. So there are 5 photometric data that you need to collect before you design a floodlight. What are they? Number 1 is peak intensity. Number 2, beam spread. Number 3, beam efficiency. Number 4, luminous intensity. Number 5, half plane divergence. So let's understand 5 of these concepts. What is peak intensity? So peak intensity, it is the maximum intensity of floodlight in the direction of intensity axis. It is generally specified in candela per 1000 lumens of lamp flux. So the maximum intensity of floodlight in a direction of intensity axis. What does this sentence mean? Maximum intensity means maximum amount of luminaires that this particular lamp source emits in the direction where it is focused to emit. So that is what you define as peak intensity. Usually it is 1000 lumens of the lamp flux. Okay, next. What is beam spread? You are observing a graph here. Okay, graph having two planes, plane A which is known as half plane A and plane B which is known as half plane B. So you are having intensity, okay, versus its beam spread taken as beta. Beta 1 and beta 2 are the beam spread. Beta is the beam spread taken on x-axis and I is the intensity taken on y-axis. So beam spread, it is defined as the angle over which the luminous intensity drops to a stated percentage, usually 50 to 100%. You are observing here in the graph on the y-axis, usually intensity of a lamp source is 100%. In half plane A and half plane B, you are observing that lamp intensity to fall to 50% each. So as your luminous flux, okay, it radiates over a surface, its intensity reduces to half, then to 20% as the light rays move over a distance. So here also it's the same thing. So మీకు డిస్టెన్స్ పెరిగే కొద్దీ ల్యూమినస్ ఫ్లక్స్ అనేది తగ్గుతుంది, అట్లాగే మీకు ఆ పర్టిక్యులర్ లైట్ నుంచి వచ్చే ఇంటెన్సిటీ, దాని ఫోకస్, దాని వెలుతురు అనేది మీకు తగ్గుతుంది. సో దట్ ఈస్ వాట్ ఈస్ కాల్డ్ బీమ్ స్ప్రెడ్. Light beams, how much ever it is spreading through a surface area, okay, more the surface area it goes, it reduces to 0%. So 100% nearby, 50% halfway, 20% 90% of the halfway, and 100% the area is covered, the beam spread is 0. So you are seeing 150 and the line The red curve you're observing, it's flat, and that is 20% of the beam spread. So larger the, I mean, more the area the floodlight has to cover, the beam spread decreases. So accordingly, according to beam spread, the peak intensity, these are the two prime factors you are supposed to consider before you take into consider the luminaires, set out by a floodlight or a flood lamp. Here, beam spread is 0 degrees to beta 1, or it may be 0 degrees to beta 2. You have taken two planes here, one half plane A, one half plane B. Okay, why we have considered two plane? It's nothing, any logic. There is no logic here. Here he just want to say that one side, okay, of the light source and another side of the light source, the intensity usually released is same. Okay, but as on both sides the light source has to travel a distance, more the distance it covers, the intensity or the beam spread it reduces. So generally, rotationally symmetric luminous intensity distribution is used for flood intensity, or sorry floodlight luminaire. So we'll understand different types of symmetric luminous intensity distributions: rotational, semi-rotational, halfway. There are four kinds of things that we are going to see next. Now in rotationally symmetric luminous intensity distribution, the intensity it remains unchanged through the same beam spread angle considered at both sides of your intensity axis. Now here in the previous slide, you have got two planes. Now both sides you are observing that it is reduced to 50%. So that is what he wants to explain here. In rotational symmetric luminous intensity distribution, the intensity it remains unchanged. So half plane A it is reducing to 50%, either half plane B also it is trying to reduce to 50%. So here the beam spread angle it is common on both sides of the intensity axis. So, beam spread angle, just now whatever we have defined beam spread, it has got an angle, certain angle. So this angle is again classified into three types. Okay, angle definition is classifying the beam spread into three types. I must say like this. So what are the three types of beam spread? Narrow beam spread, medium beam spread, and wide beam spread. So narrow beam spread less than or equal to 20 degrees. If you have got a beam spread of less than equal to the focus, okay, from that x-axis the light intensity source. From there, if you have got a 20-degree focus, you call it a narrow beam spread. Usually 20-degree focus and beam spread you observe for regular class projectors. Medium beam spread, when beam spread angle ranges between 20 degrees to 40 degrees. This usually you observe at ports దగ్గర యూజ్ చేసే ఫ్లడ్ లైట్స్లో, సీ పోర్ట్స్ ఐమ్ టాకింగ్ అబౌట్, ఆర్ ఓషియన్ పోర్ట్స్. అక్కడ మీరు యూజ్ చేసేటప్పుడు అక్కడ మీరు యూజ్ చేసే ఫ్లడ్ లైట్లో మీరు మీడియం బీమ్ యూజ్ చేస్తారు. నెక్స్ట్ వైడ్ బీమ్, when beam spread angle is greater than anything greater than or equal to 40 degrees. This usually you observe in sport arenas. So this is the different three different types of beam spread angles. Next, what is beam efficiency? See, you have understood intensity and beam spread. So from this we must now be able to define what is beam efficiency. What is, how do you define efficiency? Output to input, yes. So beam efficiency is known as light output to input ratio. Okay, so how do you define it? It is defined with certain scale. We have seen here how the light intensity in this graph 100% to 50% to 10% to 0 or 20% to 0. The intensity, I mean, the intensity of the light source is reducing as the beam is spreading over a surface. So here also we can define the efficiency in the similar way. It is defined as the ratio of beam flux to the lamp flux. Light output ratio for the beam is calculated at 10%, 50% of the peak intensity value. So beam flux, it is related to the luminaire output flux, whereas lamp flux means luminous flux. This luminous flux, where it is produced by the lamp itself in this luminaire. So this is the intensity distribution curve for a floodlight luminaire. Now you're observing whatever I have shown there, beam distribution. Okay, so the same beam distribution curve you can have here. It is nothing but this is the way floodlight is being distributed in a sports arena. సో మీకు గ్రాఫ్ అనేది యూజ్ చేసే నారో బీమ్, మీడియం బీమ్, వైడ్ స్ప్రెడ్ బీమ్, మీ బీమ్స్ని బట్టి మీకు ఈ పర్టికులర్ కంప్లీట్గా ఇలా రావచ్చు. ఇట్ మే ఈవెన్ రెడ్యూస్ టు అ లిటిల్ మోర్, ఓకే, టువర్డ్స్ ది ఎక్స్ యాక్సిస్. ద కర్వ్ మే బెండ్ టువర్డ్స్ ది ఎక్స్ యాక్సిస్, బట్ y axis obviously it's obviously going to be same. The reduction of light intensity is same, but towards the x-axis only it may little reduce. It may come closer to x-axis. The inverted U shape you're observing, that may get congested to a V or a closer V. Next, let us understand what is half plane divergence. Now, half plane divergence, it is the angular extension in all directions of a beam at both sides of the intensity axis. Observing the beam spread here, again marked on y-axis and x-axis you are considering luminous intensity. So what is half plane divergence? Angular extension of the beam in all directions, okay, at both sides. It has mentioned here both sides, but it should not be both sides, it's completely circular around. So as per the asymmetric intensity distribution diagram of luminaire, the half peak divergence usually is both one side, that is half plane A and half plane B, both considered beta 1 and beta 2. So it is coming out to be beta 1 plus beta 2. Next, what is inner beam of a floodlight? So it is a solid angle consisting of intensity greater than or equal to 50% of the maximum intensity. So greater than or equal to 50% of the maximum intensity, what is solid angle? 4 pi. So you have already defined. So whatever intensity that is covering more than 4 pi steradians, okay, it is called a inner beam of floodlight spread. Now, what is outer beam of floodlight? It is again solid angle containing all directions of luminous intensity greater than or equal to 10% of the maximum intensity. Inner ante లోపల నుంచి వచ్చే focus, outer ante once it is coming out and spreading out in all directions. This usually as it is moving further to the last, it's obviously going to 10%. మీరు ఇక్కడ beam spread diagram లో చూస్తే previous గా మీకు beam spread అయ్యే కొద్దీ మీకు 10% పడిపోతుంది. So that is what is being made to understand here. Inner beam of a floodlight, what it is, and outer beam of a floodlight, what it is. Now let us see what are the types of floodlight as per luminous intensity distribution. There are 4 different types of floodlight luminous intensity distributions. So rotational symmetry is one, symmetry above two plane, symmetry about single plane, and asymmetric. We usually for floodlighting go with the rotational symmetry. Understand? You are observing. Observe the first diagram for rotational symmetry. So in rotational symmetry, you have got 4 quadrants of the plane here. 1, 2, 3, 4. You already know how a plane is, distributed. So in 4 quadrants. See, observe the distribution. If you are considering your luminous source exactly at the center of the plane, all the 4 sides it's equally distributed. That is, rotate when you are rotating around the plane, the beam distribution, the radiation coming out of the lamp source, it's same, it's unique. I mean, it's similar. So round గా మీరు చూస్తే అన్ని డైరెక్షన్స్ లో అరౌండ్ సర్కిల్ ఇట్ ఇస్ సేమ్, ఇట్స్ కాల్డ్ for the reason rotational symmetry. So we usually go with the rotational symmetry type of a floodlight. Next, symmetry above two planes. Here you observe symmetry either in 1, 2, 3, 4 quadrants or 1, 4, 2, 3 quadrants, but not 1, 3 or neither 2, 4. It's not same. So this is either above or below or on plane A or plane B or plane C or plane D. Okay, so this is symmetry above two plane. To some focus floodlights, we use symmetry above two plane. Next, you observe the third thing, symmetry about single plane. So here you are only having symmetry of your beam distribution in upper plane. Symmetry is not at all observed in the lower plane. Plane C లో సిమెట్రీ ఉంది, ప్లేన్ D లో సిమెట్రీ లేదు. లెఫ్ట్ సైడ్ ప్లేన్ ఏ, రైట్ సైడ్ ప్లేన్ బి, అప్ సైడ్ ప్లేన్ సి, డౌన్ సైడ్ ప్లేన్ డి. సో ఇప్పుడు మనం చూసుకుంటే ఇలాగా ప్లేన్ సిలో మీకు సిమెట్రీ ఉంది, ప్లేన్ డిలో సిమెట్రీ లేదు. అండ్ ఫైనలీ fourth one, asymmetry. You observe it, the beam distribution isn't symmetrical in any of the four directions. నాలుగు దిక్కుల్లోనూ మీకు సిమెట్రీ లేదు. So this is called asymmetric luminous intensity distribution. So how many types of floodlight luminous intensity distribution are there? Four types. What are they? Rotational floodlight luminous intensity distribution, symmetry above two plane luminous intensity distribution, symmetry about single plane luminous intensity distribution, and asymmetric luminous intensity distribution. Now, let us understand the objectives of floodlighting designs. What are the prime objectives of floodlighting design? Safety and security. We want safety of people. We want security of people who are attending these sports events. So, floodlighting designs are made to provide safety and security towards the structure. Amenity. Okay, to safeguard the amenity, floodlightings are used wherever you have highway junctions. Okay, high rise lighting schemes are with floodlights are used. You might have observed. Decoration purposes, floodlighting designs are used. Commercial interiors also use floodlight design. So these are the main objectives of using floodlight design. And next, what are the applications of floodlights? Manufacturing plants, construction sites, ports, dockyards, shipping yards. Facade lightings. What is facade lighting? Front area of a building that which is facing the street or a highway. If you want to lift it elevation, you can use floodlights. Architectural buildings, monuments which are of national importance. Okay, these to elevate their architectural view, to elevate